In this lesson, we'll do a few more conversions, specifically those between degrees and fractional radians, and we'll explore the idea of placing an angle in standard position on the Cartesian plane.
Here's what we're looking at. Take the Cartesian plane for a minute. What we haven't done up to this point is we haven't considered how angles lie on the Cartesian plane. And there's a few standards that have kind of been established. First of all, if we take an angle and lie it on the Cartesian plane, we typically assume that the initial side of the angle lies along the positive x-axis, and that the second side opens up, rotating in a counterclockwise direction from there. So what that means is that the Cartesian plane now has angle measures associated with it. The positive x-axis is considered a 0-degree angle. If we rotate upward, that puts the positive y-axis at how many degrees? That makes the positive x-axis the 90-degree marker. That makes the negative x-axis the 180-degree marker, and the negative y-axis 270 degrees. Okay? So we now have relative positions on the Cartesian plane. So let me ask you this. Based on what you see there, if I told you to imagine a 60-degree angle, what quadrant would that 60-degree angle lie in? It would lie in the first quadrant. 60 degrees is certainly less than 90, and so it would probably be somewhere around right there. It would lie in quadrant 1. Okay? At this point, we'll just accept it on faith, but this fact is actually a pretty important fact and has some significant consequences for about 2 weeks when we start working with something called vectors. Okay, well, forget the 60-degree angle. Let's just do a couple more. What about a 140-degree angle? A 140-degree angle is going to put you in which quadrant? The second quadrant. 140 degrees is going to be a little less than 180, somewhere over here. It's going to be in quadrant 2. What about 358 degrees? 358 degrees will be in quadrant 4. 360 is all the way back around to 0. 358 would be a little bit less than that. 358 degrees would be somewhere in here in quadrant 4. Okay. Well, the other thing that's important is what's on the screen here. There are certain angles, specifically multiples of 30, multiples of 45, and sometimes you can argue multiples of 15 degrees, where it's convenient to express that angle in terms of pi and in radians. Well, some of those are easy to do. For example, 0 degrees is equal to 0 radians. There's not much work to do there. But based on the fact that 2 pi is 360 degrees, we could also argue that 0 degrees is 360 degrees, or that it is 2 pi radians. Well, if 360 degrees is 2 pi radians, how many radians have you got for half a revolution? Pi, 3.14 of them. So this is equal to pi radians. Now, where does that come from? It comes from this fact. Think about the conversion facts that we did yesterday, but we're going to do them a little bit differently. Let's convert 180 degrees into radians. We would take 180 degrees over 1 times pi radians over 180 degrees. That was our conversion fact. Those cancel right off, and we're left with pi radians. Instead of taking pi and writing it as 3.141592654, we just leave it as pi. So a half revolution is pi. What would 90 degrees be? That's not a full pi, it's not a quarter. It's a quarter of a revolution, but a revolution is 2 pi. That's pi, so this is half a pi, or in other words, 90 degrees is equal to pi over 2. We won't go through all of them, but you should see the general principle that's applied here. If 90 degrees is half a pi, or pi over 2, then 45 degrees, this angle right here, would be what? Half of that, which is a quarter of pi, or in other words, pi over 4. So that means this is pi over 2. Now if we go 45 degrees in the other direction, into the second quadrant, we'd have 135 degrees, which is 3/4 of the way over to 180, or in other words, 3 pi over 4. Okay, and so on. Those are all assuming positive angles. What if we had a negative angle? For example, negative 45 degrees. Positive means we rotate counterclockwise. Negative means we rotate clockwise. And so if we had an angle of negative 45 degrees, we'd be right down here. And how many radians would this be? If we go in the negative direction, it's negative pi over 4. Or in other words, 2 pi, which is a full revolution, minus pi over 4, which would be 7/8 pi. Now I'm going to show you, we're going to do a few conversions of that method in just a minute. Which quadrant will the terminal side of a 150-degree angle lie? There's the first question. Second quadrant. That's right. Answer the first part of this question. 150 degrees is going to be right about there. That's quadrant 2. So that answers the first part of the question. Second question is, write 150 degrees using radians in terms of pi. Now take that little sheet I gave you and flip it over for now. Okay? Otherwise it's too easy. You can just look on there. Here's how you do the conversion. And also, when I say you need to memorize these letters, if you don't memorize them, there's always a quick way to figure it out. It's just that you're going to be using them so often that you won't want to have to convert every time. We just take 150 degrees, use the same conversion as yesterday, and this is why we use 180 and pi instead of 360 and 2 pi. It makes the fraction work a little bit simpler. 180 degrees over pi radians. We cancel off the degrees, and we end up with that's right, 150 pi over 180, and that's our fractional measure in radians, but we can reduce it. 150 and 180 both divide by 30 degrees, and so we're left with 5 pi over 6 radians, and that's our answer. Let's do another one. 315 degrees. 315 degrees is between 270 and 360, which means we are in, I guess we did this one before when I was making up examples. That puts us in quadrant 4. Now let's perform the conversion here. We've got 315 degrees times pi over 180 degrees. (315), the degrees cancel. 315 pi over 180. (315) over 180 is going to reduce. Those are each going to divide by a factor of what? 5. You can do even better than that. 15 and even 45. Suppose you don't catch it and you only do 15. It'll still reduce down beyond that. They'll both divide by 45. This one will become 7 pi, and 180 divided by 45 is 4. So we have 7 pi over 4 radians. 315 degrees is 7 pi over 4. All right. In what quadrant will a 940-degree angle lie in? What is it? Third quadrant. How'd you get it? Yeah, 940 is too big to immediately know the answer to, but if we subtract 360 degrees, that's like taking off a full revolution. So if we subtract off 360 from that, we end up with, let's see here, 580. Still too big. minus 360 degrees again to get it down 220 degrees. Now that we can answer. 220 degrees is going to be in third quadrant. It's going to be somewhere over here. 220 degrees is the same as, if we wrap around again, there's 220. That's the same as 580, and that's the same as 940 degrees. We just keep wrapping around until we hit 940 degrees. That's the same location. So it's in quadrant 3. Now to answer our other question, what is that in terms of a fractional radian measure? 940 pi over 180. Those will reduce down. What is it? I got to check my notes because I don't remember what that works out to. What does 940 over 180 reduce to? (47) pi over 9. They both reduce by 20. Could we say that this is the same as 220 degrees and convert it over? On the Cartesian plane, yes, they'd be the same thing, right? But that one directly is 47 pi over 9. Okay, so we can go into a fractional radian. Questions about that? Now we're going to do a couple in the other direction and we'll call it good. But does that process look all right? Yeah? Okay. Well, let's go back in the other direction. This is the easier direction. What quadrant does the terminal side of the angle 3 pi over 8 lie? Well, this takes a little bit more thought. You can wait until we convert it into degrees. That's easier to think about. But just think about 3/8 pi. That's 0 radians. That's pi radians. How many radians have you got up here?
Pi over 4.
Pi over 2 up there. It's a fourth of a circle, but half a pi. Well, 3/8 pi is a little bit less than that. 3/8 is less than half, so it would be somewhere up here. We're in quadrant 1. 3/8 pi is in quadrant 1. Now let's convert that to degrees. So we have 3 pi over 8. Radians times pi radians for every 180 degrees. This time the degrees don't cancel, the pi's cancel, and the radians cancel. And 3 times 180 over 8 works out to be 67.5? 67.5 degrees. Yep, that is definitely in the first quadrant. Makes sense. Negative 3 pi over 4 radians. First of all, which quadrant does negative 3 pi over 4 put you in? Third? Fourth? First? Second? Third. Negative 3/4. If we were to go back around this way all the way, we'd hit negative pi. That's pi in the opposite direction. Negative 3/4 pi is going to be a little bit less than that. That puts us right about there. That's negative 3/4 pi, or negative 3 pi over 4. Okay, so we are definitely in the third quadrant. Now to convert that over, negative 3 pi over 4 radians cancel and the pi's cancel, and we have negative 135 degrees. Again, that's definitely in the third quadrant, so we're done. We've done the conversion. But we're going to be using these certain angles so frequently that we'll want to have those switched over and know them by memory.